Hello students, I am Tulika Banerjee. Today I bring you a learning lecture, Firearm Evidence Part 2. In this lecture, we will discuss about cartridge case, its collection and packaging and principle of examination. We will wind up this lecture with a discussion on examination of cartridge case and a case study. Dear students, recall that in the last lecture you studied about how collection of bullets and test exhibits are carried out in addition with identification of bullet and its examination. You also learnt how comparison of questioned and sample bullet is carried out in conjunction with analysis of damaged bullets. So, let's start our lecture with a look at what we are going to learn today. First is introduction, then collection of cartridge case, examination of cartridge, a case study and the conclusion. A cartridge case, also known as an empty shell, provides housing for various components of the cartridge. It is usually made of brass for rifle, pistol and revolver ammunition. The shotgun cartridge case is made from several layers of paper which are tightly compressed. The base of this paper shell is made of brass. Plastic shells for shotgun are also being manufactured now. High velocity weapons have cartridge cases which are long and bottlenecked. The base of the cartridge case may be rimmed or rimless. Rimless cartridge is used in semi-automatic and automatic firearms. Cartridge case can be classified on the basis of two characteristics. First is on the basis of case body. On the basis of body of cartridge case, it is classified as straight body cartridge case, tapered body cartridge case and bottleneck cartridge case. If we talk about straight body cartridge case, then in this type the diameter of cartridge case body is same all along the length of the cartridge case and is further divided into long cartridge case and short cartridge case. The long cartridge case is commonly used in shotgun, whereas short cartridge case is used in revolver and pistol ammunition. Next, if we talk about tapered body cartridge case, in tapered body cartridge case, the diameter of the case body goes on decreasing along the length of the cartridge case from the rim to the mouth and commonly used in rifles. The third type is the bottleneck cartridge case. In this type, the diameter of the case body is same throughout the length of the cartridge case except that a little tapering is present near the mouth of the cartridge case. The second type of characteristic on which the cartridge case is divided is on the basis of head. On the basis of head, the cartridge is divided into 5 categories. Taking up the very first category is the rimmed cartridge case. This type of cartridge case is also known as flanged cartridge. It is the oldest type of cartridge case and has a rim which has a larger diameter as compared to the base of the cartridge case. The rimmed cartridge case helps in positioning of cartridge correctly in chamber and facilitates extraction. This positioning of cartridge in the chamber of the firearm at appropriate depth in chamber is known as head spacing. In some type of rimmed cartridges, rim is also used to uphold the priming compound. The second type is the rimless cartridge case. In this type of cartridge case, the diameter of rim and base of case is exactly the same. The break formed in between the body of the cartridge and the rim is called as extractor groove, as it forms a lip which can be clenched by an extractor to remove the empty cartridge case after firing. The third type of cartridge case based on the head portion is the semi-rimmed cartridge case. In this type of case, The rim is projected slightly beyond the base of the cartridge case, but not as much as in case of a rimmed cartridge case. This small size does not interfere much in feeding from box magazine and provides enough head spacing surfaces. These types of cases are less popular as compared to others. The fourth type is the rebated cartridge case. In these types of cartridge cases, the diameter of rim is considerably small as compared to the base of the case. It only helps in extraction. It has same function as rimless case, but has some more advantages when considered in combination with other types of cartridges. And the fifth type is the belted cartridge case. The belt present on belted cases are also known as belted magnums and is present to provide head spacing. Belt is made by cutting the extractor groove. This belt acts like a rim for a rimless case. During the collection of the cartridge cases, investigating officer or IO should detach any extraneous matter adhering to without mutilating fingerprints, if any, and collect the same in the usual way. Preserve fingerprints, if any they are present. Mark the cartridge case by recording the initials, preferably inside with a pen. Record the legend found on the cartridge case in the case diary. The legend is present on the head stamp portion of the cartridge case. If more than one cartridge are to be packed in the same box, put each cartridge case in a cellophane envelope in a box with sufficient padding to avoid rattling. First, if we talk about what is the principle of examination, then the parts of a firearm which comes in contact with the cartridge or a bullet are firing pin, the breech face, the extractor, the ejector, the chamber and the barrel. They are made of steel by cutting, hammering, filing, reaming and polishing. The tools used in their manufacturing are applied at random. The cutting surface of the tools used continue to change because of wear and tear they suffer due to their action on steel. The finished surface of the relevant portions of all firearm is therefore never alike, even when the two surfaces are made with the same set of tools, one after the other. Consequently, all firearms possess an individuality of their own, means the marking or the characteristics will be individual to a particular firearm only. This has been established by actual experiments carried out in the initial stages of the development of this forensic ballistics science. A long barrel was bored and grooved with the same set of tools. It was then cut into 6 pieces and fitted to 6 firearms. The bullets fired through the barrels of those 6 firearms were correctly identified in respect of the individual barrels of the 6 firearms. The peculiarities of the surface of a firearm are enhanced with the use of firearm because of wear and tear and the accidental damage. When a cartridge is fired, the irregularities present on the surface imprint their pattern on the case or the bullet because of close contact under pressure. These patterns are also called as thumbprint of the firearm and permit their individualization. The cartridge cases and bullets are usually made of comparatively softer material than the steel of the firearm. The marks produced on surfaces therefore do not change substantially for thousands of shots, and the fired ammunition can be identified even when the firearm is recovered after a long interval. If the firearm is ill kept, misused or intentionally tampered with, this surface may change, that is, the surface characteristic will tend to change. The extent of variations will depend upon the changes so made. The fired ammunition may or may not then be identifiable. Each case has to be decided by actual experiments then. In a murder case, the firearm was buried underground for many months. After careful cleaning, it was possible to identify the fired bullet, in spite of the fact that the firearm had rusted extensively from outside. So, sometimes very old firearm is used in the commission of crime, and due to extended use over the long period, the barrel of firearm gets washed away and its bore becomes larger. A bullet fired through such a firearm does not house properly in the barrel, and hence it is not imprinted with the identification marks, that is the thumbprint of the particular firearm. Generally, this does not happen during the interval between the occurrence of the crime and that recovery of the firearm from the scene of crime. Some criminals use previously fired bullets in cartridges of higher caliber. For example, .32 fired bullet is placed in a 12-bore cartridge and fired. This misleads the investigating officer. He searches for a rifled firearm rather than a shotgun. It complicates the investigations. If a cartridge of lower caliber is fired through a firearm of a higher caliber, its bullet does not fit in the barrel and often does not take the identifiable marks. If some marks are discovered in the bullet, they are compared with fired test bullet of the same caliber as that of the firearm. In some cases, it gives useful match. Sometimes the loose bullet is marked imperfectly and the test bullet of the right caliber does not give correct match. In such cases, a lead bullet or a slug, especially prepared of slightly larger diameter than the bore, is pushed through the barrel. It takes up most of the marks from the barrel and provides useful test material. Next is identification of weapon and the cartridge case. A firearm which is manufactured in a factory will bear various marking put by the manufacturer for the purpose of identification, like serial number, maker's name, caliber, number of lands and grooves, etc. These markings are called class characteristics. These can be of help in identifying the owner. Besides this, there are several other marks which occur on different parts of the firearm not within the control of the manufacturer. These marks are called as individual characteristics or accidental marks, which are very helpful in identifying the firearm. Whilst all weapons of the same make and model will have the same class characteristics, statistically and empirically it can be shown that no two weapons will have exactly the same individual rifling characteristics. These individual characteristics are caused by small defects in the rifling which are produced during the manufacturing process. They are totally random and as such are as individual to a particular weapon as fingerprints are to a person. The parts of a weapon which imprint class characteristics on the fired cartridge case have of course been individually manufactured. The manufacturing process involves cutting, drilling, grinding, hand filing and very occasionally hand polishing also. Each of these processes will leave individual characteristics in much the same way as the boring process, which is the initial step in making a barrel. An example which conveniently illustrates the production of individual characteristics would be the final step in the production of a firing pin. After the automated manufacturing processes have produced the rough pin, the final step would be the rounding off of the tip with a smooth file. Each pass of the file across the firing pin tip will involve removal of metal, some of which will be deposited on the cutting edges of the file also. This deposited metal will alter the cutting characteristics of part of the file, which will continue to be altered further as the metal buildup continues. During the whole process, the surface of the file is constantly changing, giving an endless variety of striation marks on the tip of firing pin. Some of the important accidental marks I will discuss here. First is the breech block marks. The breech block of a weapon is usually surface finished by a milling tool or a file, either of which leaves tiny striation marks on the face of the block. At the moment of firing, the base of the cartridge case strikes with a tremendous force on the breech block, registering impressions on its surface. The marks may occur prominently on the percussion cap, which is made of softer metal than the rest of the surface. The second type is the firing pin marks. Because the firing pin strikes the primer cap with force, there will be marks of firing pin on its surface. These marks are due to imperfection, finishing marks, etc. that are different for every firearm and are rarely or almost never duplicated. The third type of marking is the extractor and ejector mark. All firearms have some form of extractor or ejector. The extractor marks are not found on pistol cartridge cases. The pistols have special ejectors which are likely to leave marks on the cartridge cases fired in it. Repeater and automatic arms normally impress definite and recognizable marks like size, shape and location on the rim of the cartridge case. Sometimes they are sliding marks of a more positive identification. The fourth type here is the marks due to expansion. At the time of firing, the cartridge case expands and may take up marks or certain irregularities which may occur in the region where the barrel and the breech block and the extractor meet. A good example of class and individual characteristics can be found on many of the 7.62 x 25 mm caliber type 54 Chinese military pistols. In these, the end milling striations from the standing breech are clearly visible on the fired cartridge case. These are often mistaken for individual characteristics, and it is very easy to make an incorrect identification on this basis, as the class characteristics run in an arc across the standing breech, the gross milling marks and the individual characteristics, that is the fine finishing marks, run from top to bottom. If the cartridge is turned through 90 degrees, the individual characteristics reveal themselves. Location and recovery of projectiles through X-rays. So, we cannot part with the case without making reference to certain defect in the investigation and in the conduct of the doctor who held the post-mortem examination on the dead body of Pravakar. According to the post-mortem report, there were gunshot wounds. The entrance wound was noticeable but not the exit wound. It was the duty of the medical officer to have directed X-ray examination of the dead body to determine if bullets were located in the body. It was the duty of the IO to see if bullets were inside the dead body and if those bullets recovered were proved to ballistic expert, admittedly belonged to Srinivas and from whose possession it was recovered. We cannot disabuse our mind of the impression that this omission cannot but a deliberated one. The matter was so obvious that no investigating officer would ever ignore it. So, identification of bullets in cartridge cases is very necessary when firearm has been used in the commission of crime. At this instance, one should have complete knowledge regarding the various types of cartridge cases. Based on the type of cartridge case, body and head of the case, moreover, in addition to it, the class and individual characteristics needs to be properly studied for the purpose of comparison and individualization.